Massive galaxies that scientists thought could not exist have now entered the realm of possibility thanks to the latest discoveries. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. It is therefore exciting and worth keeping an eye on these developments, as they could fundamentally change the framework of how we perceive cosmic evolution, structure, and origins. Among those at the forefront of this emerging discourse is Michio Kaku, an outstanding figure in the scientific field. A physicist of both American and Japanese origin, Kaku is widely recognized and respected for his contributions to theoretical physics. He is considered an expert in both classical experimental physics and the more elusive realm of quantum mechanics, bridging the gap between traditional approaches and cutting-edge theories. Unlike some more conservative and skeptical scientists who tend to resist radical shifts in paradigm, Kaku does not belong to that group. Instead, he has been openly receptive to the amazing results of the James Webb Space Telescope mission. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied, that these findings may fundamentally challenge the very basis of modern cosmology. The enthusiasm and almost awestruck tone of the renowned stellar physicist is evident in his comments on the discoveries made by the James Webb Space Telescope. Kaku has expressed that this has been the highlight that has piqued his interest more than anything else in recent scientific developments. His passionate remarks signal the gravity of these revelations, emphasizing just how profound their implications might be. Join us as we explore and discover the implications of Michio Kaku's reflections on the discovery of these 6 massive galaxies. Michio Kaku is a scientist who has always been willing to consider new theories throughout his life and career. He is fully aware that Einstein's equations of relativity, while groundbreaking in their time, along with Newton's laws, are insufficient to capture the full complexity of the universe in its entirety. Kaku understands that the discoveries enabled by the James Webb Space Telescope have the potential to enrich the scientific field beyond anything we've previously imagined. Although many of his colleagues have not yet been able to adopt this open-minded view, and despite the fact that it is generating significant concern and even insomnia among both proponents and opponents of the Big Bang theory and quantum mechanics, Kaku finds the controversy more amusing than disturbing. This only provokes laughter from him, which speaks to his calm confidence in the face of disruptive knowledge. The James Webb Space Telescope has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe, each of these galaxies containing more stars than our own Milky Way. Despite having formed only 200 to 700 million years after the Big Bang, the team of astronomers who may have made this groundbreaking discovery have dubbed these exceptional galaxies universe breakers. The reason is clear: if confirmed, they would revolutionize our entire understanding of the cosmos. Something doesn't fit here anymore. The prevailing Big Bang theory tells us that the cosmos was a hot mess immediately after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for those objects to reach sufficient density to produce light and evolve into larger structures. The formation of complex entities such as galaxies was assumed to occur much later. Yet, some of the newly discovered galaxies actually exceed the Milky Way in size. Their immense luminosity indicates that they were probably forming hundreds of new stars each year, a stark contrast to our own galaxy, which forms stars only sporadically. It remains uncertain exactly when the first galaxies formed. Researchers have not been able to determine this with precision so far. The only thing that is clear is that initially there may have been only single stars or small groups of stars, which eventually joined together to form larger and larger accretions until dwarf galaxies developed. These small galaxies likely encountered other galaxies and gradually grew through gravitational attraction and merging processes. According to previous theories, highly organized and massive galaxies could not have existed at that time. This raises 2 equally astonishing questions. Is the universe much older than previously believed, or did complex stellar and galactic arrangements develop much earlier than expected? This circumstance is particularly difficult to accept for conservative branches of science, which still find significant problems with this model. Some sectors of physics vehemently refuse to accept this discovery and are questioning whether errors in the age calculations might be responsible for the surprising results. Michio Kaku was aware of this resistance and had this to say: "There are many examples of old and false theories that stubbornly persist because of the prestige of some scientists." He emphasizes that many of these outdated theories were only discredited when a crucial experiment revealed their falsity. Therefore, he contends, the fundamental work in any science, especially physics, rests within the hands of the experimentalists, those who keep the theorists honest. In fact, on Earth, we still know very little about the true beginnings of the cosmos. The Big Bang theory was first established in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for both laypeople and scientists to conceive of a universe that had a definite beginning and might one day have an end. The idea of a universe that had always existed and was infinite in both time and space was deeply ingrained and beyond most people's imagination. Even today, scientists still face major difficulties in fully understanding the origins and fate of the cosmos. However, it is important to consider these new probabilities. Once again, these latest demonstrations and observations do not fit at all with what researchers have based their work on for decades using the Big Bang theory. Nevertheless, science has shown time and time again that re-evaluation and openness to new ideas are an integral part of the scientific process. This includes the confirmation of certain theories and observations, as well as the rejection of others that no longer hold. When Michio Kaku was a child, it was still widely believed that the stars and planets were firmly fixed in the universe, each occupying a defined space that did not change. However, we now know that everything in the cosmos is in motion. Planets orbit stars. Stars move within their galaxies at speeds of hundreds of kilometers per second. Entire galaxies themselves move rapidly through the universe on vast trajectories, the fate of which we cannot yet even predict. Today, scientists are being challenged to accept uncomfortable truths and to understand that scientific theories are not permanent gospel, but rather well-informed guesses. They are not absolute truths unless they are rigorously tested or confirmed by accurate observations. The idea of the Big Bang arose from the realization that galaxies are moving away from each other, and this movement is proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe is expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies, as well as other cosmological structures, seemed to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the Sun revolved around us also had what they considered evidential support for their assumptions. That persisted until either coincidence or technological improvements came along that provided a clearer and more accurate picture of reality. Right now, we are witnessing a similar situation. Scientists expected the new James Webb Space Telescope to confirm the assumptions related to the Big Bang theory. But instead, they have come across these 6 galaxies that seem outright impossible under that model. This reminds us that science is constantly evolving and that scientists must always remain open to new discoveries. They must be willing to rethink existing theories based on the evidence available at any given time. Researchers use redshift as a primary tool to determine certain key quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and observer move relative to one another. To understand this better, imagine yourself standing still and seeing a car coming towards you. As the car approaches, you hear the sound of the engine getting louder. However, once the car passes you or moves away, the sound of the engine changes pitch. This is because the sound waves are compressed as the source approaches and stretched as it recedes. The same is true of light. When a light source such as a distant star moves towards us, the light we perceive shifts toward bluer hues. On the other hand, when the light source moves away from us, the light shifts toward redder hues. This phenomenon is called redshift. Physicists have converted redshift values into velocities and distances to measure and interpret cosmic structures. However, it is important to note that even small errors in these measurements can have significant effects on the conclusions drawn. The measurement techniques previously used are now under intense review. It will be very interesting to see what results scientists arrive at in the coming years as they reassess these methods. As for the latest demonstrations and observations related to our cosmos, it is necessary to consider whether they are truly based on redshift errors or whether some scientists are simply denying the facts due to psychological or institutional resistance. This is a question that requires rigorous analysis and careful review of both the data and the methodologies used in the research. In summary, the 6 massive galaxies observed by the James Webb Space Telescope present a direct challenge to long-held assumptions about the early universe. They force us to confront the possibility that the cosmos is either much older than we believed,